Welcome, everybody. We're here to talk about JavaScript tests in Node, the browser, and CI. If you're watching this online, then the slides are definitely over here. If you're here in the room, the slides are definitely over here, except for there are no slides. This is demo only. So here's the part where I say thank you. Here's the part where I say I'm definitely going to post the code on my blog tonight. You're going to email me tonight. You're going to look tonight. You're going to look tomorrow, next week, next month. In about 3 months, you're going to go looking for the code that we deal with today, and you're not going to find it online. You're going to email me, and I'm going to say, no, I'm definitely going to post it on my blog tonight, and I'm never going to post it. Has anyone ever done that at a conference? Yeah, stop those people and tell them to quit it. So you can go to robrich.org right now, right here, robrich.org, click on Presentations, and you can scroll down to JavaScript tests in Node, the browser, and CI, and click on this code link, and you'll get to the GitHub repository that we're going to look at right now. The cool part about this repository is there's a start folder and there's a done folder. The start folder is where we'll begin today, and the done folder is my solution. So you can do the exercises as well, and you can compare and contrast your solution with mine, tell me where I did it wrong, and so that is online right now. While you're here, click on About Me, and you'll get to this page, and you'll see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. AZ GiveCamp is wonderful. AZ GiveCamp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software Friday after work. Sunday afternoon, we deliver completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come look us up because that is a lot of fun, AZ GiveCamp. Some of the other things that I've done, SQL Source Control Basics. Mine is Chapter 8. That was a lot of fun. I worked on the Gulp project in version 2 and version 3. I do training. Git is a great company for doing Git training, and I also do JavaScript and ASP.NET training, and some of the other user groups that I'm associated with. This one is the Southeast Valley.NET user group. I was speaking in California recently, and they said, that's by Hollywood, right? It's actually the Southeast Valley.NET user group in Phoenix, so that one's in Chandler, Arizona. One of the things I'm particularly proud of is I replied to a .NET Rocks episode, the podcast. They read my comment on the air. They sent me a mug. Woohoo! And if you'd like a mug, you can write a comment. No, I'm just kidding. So let's talk about JavaScript testing. JavaScript testing. Let's start out in Node. And the first thing, I love the way Dave Ward explains it. He says, let's do, oh, there's already a folder called test. Awesome. Time to first it. Hello-world.js. I want to do the first test. It. Thank you, Visual Studio. It should pass. Assert true. It is true. OK, we want to pull in the assert library. Time to first it. We have a test. And we can come here to the command prompt, and we can run that test. And we have a passing test. Woohoo! Time to first it. A second and a half. So what did we just do? Well, I've started out by installing Mocha and Chai. Mocha is the test framework that we'll use. Chai is an assertion library. In this case, we didn't use it. But I just installed those NPM packages. And so when I do NPM install, those things will pop up. And then here in our test, each test is a function. So we have this it. It defines two things. The first one is the name of the test. We saw that here. And then the second one is the function that should run. So in this case, assert will validate that this is truthy. And if it is, then our test passes. So if I change this to false and rerun the test, then we see that now my test is failing. Time to first it. So that was really cool. We can also wrap our test in describe blocks to kind of group them together. describe hello world. And that will then allow us to group our tests in interesting ways. So we can say this group of tests applies to this file, and this group of tests describes this file. And so let's make our test pass again. Now we have them grouped into this group. OK, so let's go write a real test. I have this library, and it's intentionally simple so that we can focus not so much on the business logic of our problem, but more on the tests that we want to write. So here's this add function, and let's go write some tests for it. Here in my test folder, new file. Let's say add test.js, describe add. I will pull in chai. And I'll actually use the expect syntax here. So I want to say it should add 2 and 2. So arrange, act, assert. This arrange, act, assert pattern allows us to kind of clearly identify the steps where we're setting up the condition that needs to happen, and then we'll do that condition, and then we'll validate the results. So I want to say const x equals 2, const y equals 2, const expected equals 4. I'm going to act. I'm going to say const actual equals add x and y, and we will assert expect actual to equal expected. Now we need add, so let's go grab add. And let's run this test. Now I'm running mocha from the command line. We could choose to include in our package.json commands that would run this with npm test. So let's actually do that. Here in the package.json, I will say scripts test is mocha. So whenever I type npm test, it will run mocha for me. So I can say npm test, and away it goes. And my build server will probably want to do that. It'll run npm test and go kick off all the things. So this is JavaScript, and adding things is really interesting. So let's do something like this. It should add A and B. Don't we just love JavaScript? So if I add A and B, then I would expect this answer to be AB. And there's that test passing as well. Time to first it. We are able to run some tests, and we now have them nicely grouped, and we're able to flex our library in interesting ways. So we have another library, and like all good programmer, I'm just going to copy and paste this. Let's go into the subtract library. I will hide add, or I'll replace add with subtract. And in this case, 2 minus 2 is 0. And subtract doesn't work this way, so I'll remove that test. And let's run our tests again. CB is not a function. OK, let's go dig into the subtract library and understand how that works. Well, this subtract library doesn't quite use that return the value thing. Rather, this is an asynchronous function that takes in a callback. That's easy enough. Here in our subtract test, rather than calling subtract right here, and getting the value, we'll just pass in that callback function. And then we'll do this assert here. Now the cool but annoying part is that this test doesn't know when I'm done. How does it know that I'm doing an asynchronous thing or that I'm not? So if we pass in done here, we can say whenever I'm done running my function, I'll actually call done, and that will signify that all the asynchrony is complete. So let's fire up this test, and now it passes. We're able to run an asynchronous test using a callback. So what happens if I don't call done? Well, in this case, it passed because I wasn't doing anything that took too long. But now I get this timeout that says, timeout of 2,000 milliseconds exceeded. We've run longer than we expected to. And ultimately, that failed that test, which is really cool. Well, if 2,000 milliseconds isn't sufficient, I can say this.timeout equals 5,000 milliseconds, or 10,000 milliseconds, which works really well right up until I get really clever because, ES6 is awesome, and I go like this. And now this means something completely different, which is why I didn't do that in this case. If you're going to use this.timeout, then you'll want these to be regular functions. If not, yeah, go ES6 all the things and enjoy the arrow functions. So I would like this test to run quickly. I'm going to undo that. And now that I'm not using this.timeout, we can ES6 all the things. And let's run our test. And now everything works. A synchronous test and an asynchronous test. Well, let's go look at the multiply library, because the multiply library is going to do something interesting. The multiply library is going to return a promise. So now we have to .then to go execute this one. So let's create a new test. We'll save this as multiply.test.js. Subtract becomes multiply. And because 2 and 2, I don't know if I'm adding or multiplying, I'm going to multiply 2 and 3. And then this isn't a callback anymore. I'm going to .then. Now the one cool thing about .then, and let's actually make this an arrow function because that'll be cool, is I may also have a catch. I may have an unhandled exception here. Promises may throw. Well, the cool part is I can pass to this done function an argument, and if I pass in a truthy argument, it will fail my test. So here I've said catch an exception and pass that to done, in effect, fail my test. So if I succeed, if I correctly add, then I'll be able to do all these things, and if I fail, then I will fail my test. And that works out just fine. Well, that's really cool, but I may have an async await type of thing. And so what's really cool is Mocha can actually return promises. Should return promise. So I can say instead of that, I'll just return. And I won't take in that done parameter anymore. And now that will work as well. Because I can return a promise into Mocha, I can now fire off that test in really interesting ways as well. Well, promises and async await are really cool. They're really close neighbors. So I'm going to say this is an async function, and I'm going to await that. Oh, const actual equals await. And now I'm able to kick off my asynchronous functions, my async and await functions as well. I've just chosen to return a promise here. I do all of the awaits that I need to do, and then I just fire off my code. And now those tests pass. We did a synchronous test. We did an asynchronous test with callbacks. We did an asynchronous test with promises. And we did an async await test. Any questions so far? Well, this is really cool. Let's go do this, but for divide. So I'm going to go grab this. Let's create a new file. Divide test.js. And I know that my divide library is synchronous. It works like add. So I'm just going to say const actual equals divide. I will assert this. Now, this isn't an asynchronous test, but I'm going to leave this done in just in case. In places where I'm not doing async and await, I like to have this done here and this done here so that I know that I didn't miss anything. I know this is a synchronous test, but I'm still treating it as if it was asynchronous. So 2 divided by 2 is 1. And let's run our tests, and they pass. Well, divide has another condition, and so let's test that as well. It should divide 2 and 0. So in this case, because I'm dividing by 0, I would expect it to throw. So there's ways that we can do, expect throw type of things, but the most discoverable way, our tests are helping us document our code, is to just have a try catch here. So now I expect actual to not do anything, but I expect to have an exception. So let's have undefined be here, and I won't use actual here. I'll just throw away the results, and I'll say actual equals error. Now I expect actual dot message to equal can't divide by 0. And in this way, I'm documenting my code. I'm documenting that I expect it to throw an exception. I'm catching that exception, and I'm asserting something about that exception. Let's run our tests. Ooh, we can't find message of undefined. We just used our test to kind of discover the contents of our library. We could write tests about a library we don't understand or about code that is unfamiliar. Let's go look at legacy code and see if we can wrap some tests around it. So let's go look at that divide code and see what happened. Well, it looks like the clever developer that wrote this decided that divide by 0 was something they needed to handle more carefully. Yeah, that's not how math works. New error can't divide by 0. So we used our code, our tests, to discover, oh, save as a thing. Message of undefined, oh, return. We used our tests to discover failures in our library. const can't change. There we go. Now we have passing tests. In places where we don't understand something, it might be a good idea to start with a test and explore how that behavior works in lots of conditions. Let's kind of understand the boundary conditions of this code, and let's write tests that flex it in interesting ways. So now what's really cool is we hook this up to CI, and CI says npm test, and we get either a success, a 0 return code, or a failure, a non-zero return code, and we'll be able to harvest these results and do all the things. That works great for our server-side code. For client-side code, we want to run these similar things in a browser. So I've done a similar thing here. Let's close all of these, close all to the right. I've installed Mocha and Chai again, and I've also installed jQuery because perhaps our application uses jQuery. And I'm going to say mocha init. Oh, the path. Mocha init in the current directory. By typing mocha init, it's going to go create those browser files that we need. So it created this index.html, and this index.html then references mocha and is able to kick off our tests. So here's our tests, and right now our tests are empty, and that's okay. Let's just go grab all of our tests from this folder. Paste them in place, and we'll modify our index.html to reference our tests. So add test, subtract test, multiply test, divide test, and we're also going to reference our code under test, our libraries. It's 2018. Why can't we self-close script tags yet? I'll pull in jQuery. OK, so we've got our tests ready to go. Now these reference Chai. So let's go pull in Chai as well. There's Chai. And now what's interesting is that these Chai tests reference Chai as a variable much like jQuery. So here in our add test, instead of saying expect equals chai.expect, we don't have require anymore. So we'll just reference chai.expect. And because they're all running in the same window, let's say this is let, and the add library already exists, so we'll just copy that out. Add test, divide test, multiply test, and subtract test. And now let's go fire up this index page in a browser. Here's that page, index. And it ran a few of our tests, which is wonderful. We have 2 passes. We have no failures, but it didn't run all of the rest of them. Well, this is a browser. Let's hit the F12 developer tools. Oh, hey, something's new in Chrome 70. Expect has already been declared. OK. So often what we'll do instead of this expect right here, so that we'll only define it once, much like it's doing this mocha setup, we'll just go define expect right there as well. And because we're defining it in one place, now all of the others can just assume it's there. And now I'm not redefining this variable a bunch of times. Save all. Ooh, yes, don't want to save that one. And now I'm running all of my tests. Now we see that we have a test failure. What's really cool about this test failure is not only do we have a failure, but we have the message that it threw out. We can dig into that test and see the actual code that ran. And in this case, we say, cannot read property message of undefined. Well, we saw that before. I'm guessing that that clever developer that created this divide library did that same bug. Yep, there's that divide by 0 is an interesting way to go. So let's go fix that. And we can rerun our tests. And we see they all succeed. Multiply test does not exist. Did I name that weird? That is weird. Ah, yes, it does. Thank you. I'm going to multiply. So I've got all the tests in the browser, and I may want to zoom into a particular set of tests. If I click on multiply, now it's only showing me the multiply tests. And I can dig into one, and it'll show me the interesting details there. Now what's cool is I can say, well, I'm working on this multiply test, and I want to go look at how this works. Well, this is JavaScript. Let me just put a debugger there or set a breakpoint in Chrome, and I can now step through how that test works, looking at all of the variables that I have associated with that content. I love that I have this great way of exploring my tests in really interesting ways. Now we got a timeout because I was debugging. That's fine. Let me run that again and not stop for 2 seconds, and now it runs. Well, it did pause for 1.4 seconds, but that's okay. I love that it highlights slow-moving tests as well. So we were able to test our things in back-end node code, and we're able to take those tests almost unchanged and put them into the browser, debugging our tests, exploring them. We still have asynchronous tests. We still have async await tests, which, by the way, is supported in every browser now, except for IE. We have promise tests. We have all of the tests, and we have them now in a browser running just fine. Any questions so far? Well, let's take this to the next level, because now I want to talk to CI, and I want to say, okay, Selenium, can you just pop open a browser and go poke at all the things, and once the browser is done, can you then close the window? And yeah, that's not really how that works. So instead, let's see if we can take these into a CI environment where we can run something like we ran before, where we said mocha, and it just ran all of the tests. Or ideally, let's run npm test and have it run all of those in-browser tests. So here's step 3. And here in step 3, I have installed Karma. That's not it. Package.json. I've installed Karma. And Karma is that test runner. Karma will wrap Mocha, fire it up in the browser of my choice, and run all of my tests. So here, let's say karma init. Ooh, cannot find optimist. The most dangerous thing to do on stage. Let's npm install and see where optimist fell off. It looks like the internet is doing just fine. This is wonderful. Oh yeah, they are wonderfully scary. What I really love is this new message down the bottom that says, found 6 vulnerabilities. Karma init. I love this part because karma init is going to kind of interview us and ask us questions about what is the test framework that we're going to run, what is the environment that we want to run in, what are the conditions that make this so. And so we're going to say, well, we're running mocha. Do we want to use require.js? No, we don't. What browsers would we like to run in? And we can then go pick from lots of them. In this case, I will just choose Chrome. And now I could pick more if I wanted to. What is the location of my test files? I'm going to say star.js. Should any of the files be included yet or excluded? Let's exclude node modules. Do you want Karma to watch all the files? Yes, let's do. Now what Karma created for us is really elegant. It's here, this karma conf.js, and it is, in effect, the answers to all of the questions that we created before. And it has a few more things in here, which is kind of interesting. But I'm going to also add the chai library, so it'll make sure that we have our assertions ready to go. And then let's go copy all of our tests. And because we're grabbing all of the tests in all of the places, we're just looking for star.js. It will grab all of my test files and all of my regular files and just do all the things. OK. Karma start. So now Karma is going to launch. It's going to do all the things. It's going to run all my tests. And it's going to note that a lot of tests failed. Expect is not defined. Expect is not defined. That's pretty cool. So I have chai, but I haven't defined what expect is yet. That's cool. Add test. Now I just saved that and rerun, and it's going to go kick off my tests again. Chai is not defined. So apparently I did not pull in, helps to save the karma config. Now I need to stop the watch because I changed the config, but if I just save my tests, then the tests will come back. So now we see that we ran all of our tests in Chrome, and all of the tests passed. So of course, this window is really annoying, so I'm going to close it, and Karma's going to help me and go, hey, I think I lost the browser. I'm going to go launch it again. Thanks. But I don't want that window, but it's going to launch again. And there it is. So yes, on your left top monitor is a version of Chrome that will probably be full screen forever. Yeah, sorry. There is a way to run Chrome headless, and it's actually not that bad. So we see that one test failed. We're dividing by 0 again. Let's go back into our divide library. And I bet we didn't have this in place. So let's set that in place. And now all of our tests pass. Now the cool thing is, this is a command that we can run from CI. We can say karma start, and it'll go run all the tests, and it will give us back an answer. But this is watching all the files, and we like that. As we're developing, we like kind of having this test window off in the corner, and we'll just see it and do all the things, and then we can just poke at it and see content coming and going. But in this case, we want to say karma start dash dash single dash run, and that will run once. It will kick off the test. It will finish. There's a typo. Sigil run. It will go launch the tests, and it will ultimately end. And so now if we look for a status code, we see that it returns 0. And that's the command that will get our CI server to run. So karma start dash dash single run. Let's go back into package.json. And let's set that as our script, our test. So now we can just run npm test. Well, in this case, not only am I saying single run, but I'm also saying in Chrome headless and in Firefox headless. And now I can go kick off those tests in both browsers. It won't launch any UI on my build server, and I'll be able to get the results of these tests across those two browsers. Any questions so far? So we've got our test to run server side, we've got our test to run client side in Mocha, and we've gotten our test to run client side in Karma, which is wonderful. So then, should I use Karma or should I use Mocha? I generally set up both of them because I find Mocha a little bit easier to debug. There is a nice debug button right here, and you can do it. What it does is it will launch the tests here. Now, I'm not seeing any UI because my tests aren't writing anything to the UI, but if I open the F12 developer tools, then I can do my same mechanism of setting the content, setting breakpoints in my tests, and I can just walk through that. That's okay, but I personally find the Mocha debugging experience a little bit more fun. I can also group tests easier. So I'll generally set up Karma, and I'll set up Mocha, and I'll be able to run both of them. Any questions so far? So we have one more thing that we want to do is we have this Ajax lib, and we want to be able to test this. Now this Ajax lib is interesting, but there's a lot of moving parts. It calls off into jQuery. And ultimately, we don't want to make a web request. We want to just run this test locally. So let's create a new file, ajax lib test, describe ajax lib test. It should test jQuery. And for the sake of the time, I'll just say, it's in the done solution, but I want to mock $.ajax. OK, so let's say $.ajax equals function, and this takes in this object. So here's an object. And inside this object, we're going to call the success handler, passing in some data. And we can define whatever data we want that to be. We've now mocked jQuery so that when we actually run our test, it will run this function instead. Well, as a good citizen, we also want to clean up after ourselves. So we're going to say after each $.ajax equals real Ajax. We're going to put jQuery back in case some tests need to actually run jQuery. And we'll grab our pieces at the beginning right there so that we can be able to put it back. So now we're able to mock our function, and I'll leave this up to the reader to be able to call into that function, pass in your data, your mocked data here, and then validate that that is what you expect. So the cool thing about JavaScript is we can monkey patch anything. So you definitely can use a mocking library like Sign-On, and that'll give you a lot more power here. But you can also just mock the things that you need to overwrite. And that works out just as well, too. Any questions on mocking and testing in JavaScript? Good question. Do we need external libraries to do async and await with Mocha and Chai? We don't, because browsers have async and await baked into them now. And so it just exists. In Node, ever since Node 7, we've had native async and await support as well. Because async and await is just promises under the hood, and Mocha has supported promises forever, then it just works. If you're not on Node 7 yet, Node 8 is the old LTS version. Node 10 is the new LTS version as of October. And so you should have promises available, and thus async and await available to you everywhere. If you don't, upgrade. This has been a lot of fun. Thanks for letting me play.